Welcome to the next tutorial in the series. Today we're going to be looking at how to use images instead of word stimuli in our experiments, and we're going to look at gathering ratings at the study phase, which we can use to classify items during the test. So to do this, we're going to go back to our original experiment, Demo 1, that we created, which loaded in 6 words to be used as a study phase and 12 words to be used as in the test phase. Now, in order to start using images, we need some images. So I have gathered together 12 pictures that we can use. These are pictures drawn from Google Street View, so I'll load them up here. These are images of Toronto that we use in some of the experiments in our lab. It doesn't really matter what images you're using, these are just the ones that we're going to use. And so you can see they're very wide images. They're actually panoramic images, but you don't need to know what that is for today, you just need to know they're very wide images, and this is what they look like. So how do we get these into our PsychoPy experiment? Well, let's start off on the welcome screen just to introduce an image so we can see how the image object works, and obviously then we'll work it into our study trial. So let's insert a new image object. We're just going to call this image test. The image will appear for an infinite amount of time, just like the welcome screen. We'll leave everything else as default, and we'll just manually enter in the name of an image. So the script is running from this folder here. So the images are in this images folder. So in order to indicate where the images are, we have to start by indicating the folder, and then we put a backslash, and then we can pick a file here. Let's go ahead and pick this one. Now you'll find these images on the lab website that you can download if you want to create this experiment along with us. Okay, so I've inserted one of the images randomly picked. I think it was the third or the fourth image. Yeah, the third image in there. I'm just going to click OK, and I'm just going to run the experiment to see what does that look like. Oh, and actually before I do, I'm going to save this file as a new file so that we don't have images in our original file. So we'll just call this Demo 3. Again, use better naming conventions than me. I don't know why I'm just stuck on using Demo 1, 2, and 3, but it's the way it is. So we say OK, and our image loads. Now this is the image, but you'll notice it's not being displayed correctly. It's all squished, and there's something wrong with it. So let's go back and look at our image properties and see what was going on here. So if we click on our test image here, and we look at its properties, we have its position on the screen. Again, 0, 0 means center. That's good. But then we have the width and the height, the size of the image. And its size is being represented here as 0.5 and 0.5. Now, if you remember, the entire width of the screen is 2 units wide. So 0.5 actually means to take up 1/4 of the width of the screen. That's actually too narrow. We need this to be much wider. So we're going to go ahead and switch the width to 2. So the image will extend across the entire screen. Now in terms of the height, we actually don't want our image to be that much taller. 0.5 is fine. So we could just leave this as is. Maybe about 1/4 of the height of the screen seemed pretty good. So if we look back at how the image is supposed to look, yeah, that's about 1/4 of the height of the screen. So that maybe will be okay. So let's just say OK, and let's just click Run, and let's see what happens. Now the image is being displayed a bit more correctly. It still looks a little squished, so maybe it should be a little taller, but you can see that we have now changed the width, the entire width of the screen, and now we can effectively see the entire image. So when you're introducing images, you actually have to pay some attention to the width and the height of images. If you have square images and you don't mind them being only about 1/4 of the width and 1/4 of the height of the image of the screen, or not even square, it has to be the dimensions of your screen. So if you have a wide screen like we've got here, you have to have a widescreen image. But if you're okay with the image being sort of small in the center of the screen, these dimensions are okay. But if not, you have to change them. And by the way, if we wanted the image to take up the entire screen, we could set it to 2, 2, and then whatever the size of the image, it will stretch to fill up the entire screen. So you can see here, this is what our image would look like if we used width and height of 2, 2. Obviously it's distorted, it's too tall, it doesn't need to be that tall. Now when you are creating your own visual stimuli, there's 2 tips I want to give you guys. First of all, whatever dimensions your images are, make sure every single picture you use in your experiment are the same dimensions. Because when you're setting up your image objects, you only set the width and the height once, really. I mean, you could get fancy and make these variables that are updated every iteration, and then in your stimulus file you could give custom widths and heights to all your pictures if you want to go that far. But the far easier thing to do is just make sure that all your pictures are the exact same dimensions. It doesn't matter what those dimensions are, you'll get the width and the height set up correctly once, and then everything will be fine. If your images are all different dimensions, it's going to create problems. One other tip is that you can't crop images in PsychoPy, at least not as far as I'm concerned. I mean, I haven't seen the feature in there and I can't seem to find it. So if you do want to, let's say you're looking at your images and you say, you know what, I don't want these super wide images. I would rather just have a much more narrow view of each street. Then what you're going to have to do is go into your images and you're going to have to use a photo editing program to basically crop your photos. And so we'll just save this, call it demo. And we can go ahead and see what would happen if we loaded that demo file. So see, demo is not a very wide image like the others. It's a much more normal sized image. And we'll go ahead and return this back to default and just see what it looks like. 0.5 and 0.5. And you can see that it doesn't look too bad. Again, it's about a widescreen image, and our monitor is about widescreen, so 0.5, 0.5, this is how an image would appear by default. If we want, we can stretch it out in all sorts of weird ways, so we can make the width extra wide, even though it's not meant to be an extra wide image, and it would appear something like that. We can also go ahead and have it take up the entire screen. So if you want to display images in PsychoPy, think about the dimensions of your images and how you're going to get them to appear on the screen, and then you'll have to play around a little bit with the width and the height, and you might have to go into a photo editor and crop your images. Just make sure that if you are cropping your images, that all your images have about the same dimensions. Otherwise, they're going to look distorted, where some will be stretched in weird ways when you actually use them in the program. Okay, so let's remove this test image because we don't want this in our experiment. Instead, we want to go ahead and edit the study trial. So rather than having words, we want to have images instead. Let's have the images appear for an infinite duration because we're actually going to get ratings during this study phase, unlike in the word experiment. I'm going to go ahead and preemptively set these to 0.2, and we'll set this to 0.7, let's say, because it needed to be stretched vertically a little bit more. And in terms of image, we're going to get a variable for this, and we will call this variable image name. Or actually, how about image file? That makes more sense. And we're going to go ahead and remove our word because we no longer need it. So now in the study phase, subjects are going to see 6, and we should relabel this too, call it image study. So subjects are going to see 6 study images. And we now need an Excel file where the experiment can find those file names. So we're not going to use word stimulus anymore. We're going to need to create a new file. So before we select anything, we obviously need to go and create our file. So we'll create a new Excel worksheet here. We'll call it image stimuli, and we'll open that up. Okay, so we need a variable called image file. We also are going to want to keep track of the old new status. We learned from before that we should have that. There really isn't any other characteristic that defines my images. I don't have rural and suburban. I don't have familiar and unfamiliar. I don't have day and night, north or south, anything like that. So there really is no other variable that I need to keep track of here. So for our purposes, the first 6 items are going to be old. And then after that, everything will be new. And we'll have 12 items in total. 6 and 6. Great. Now, for the image file, so we need a variable that tells PsychoPy where all these images are. So every variable is going to start with images / because PsychoPy needs to know if we're running from this folder, I need to look in the images folder before I'm going to find any images. And then from there, we basically just copy these file names over and make sure that we're typing in the full file name. So the entire file name dot, in this case, JPEG, JPG. There are PNGs, there are BMPs, there are all sorts of different image files that PsychoPy can load. This happens to be the ones that we're using. So this process can take a little while. but just put on some music, sit back, and make sure you're entering things correctly, because you don't want to make mistakes, because then your experiment will crash. Oh, and by the way, don't make mistakes like I did. I typed in /JPEG. That should be .JPEG. While I'm doing this, another tip to think about is when you are getting image files, make sure you have some kind of naming convention. Notice how all my files are named pretty much the same. There's some mixture of longitude and latitude coordinates, _pan, and then JPEG. You know, if you are gathering stimuli to use in an experiment, again, use good naming conventions. Be tidy with things. If you come up with sloppy names like, you know, apple, fruit, kiwi, something like that, and then you also have tools or other objects, then later on it might be really difficult for you to go back into your stimulus folder and easily look at the number of fruits, the number of tools and stuff you have, because things are just going to get listed alphabetically. So maybe you might want to have a better convention where you first identify the kind of image it is. So you'd say fruit _ apple, fruit _ orange, fruit _ kiwi. And then you'd have tools _ hammer, tools _ wrench, tools etc. So that things are nice and organized, and it's much easier to see what's going on in your file. So organization is important, guys. I've said it a number of times throughout these videos, so just don't neglect it, because it's easy to neglect and think in the moment I'm not going to bother naming things, but then you're going to come to regret it later on when you're trying to deal with your stimuli or analyze your data, that kind of thing. Okay, so we've successfully entered our images into the Excel document here. So now what we can do is we can select that file as our condition file, and it detects 12 conditions with 2 parameters. I'm selecting items 0 through 6 to get the first 6 images. Remember, computers start counting at 0, so 0 is the first item, and then we want to go up to stop at 6, so we'll get the first 6. Check my earlier video out for the logic of this, but that is how you get the first 6 items. So we want 0 through 6. Number of repetitions 1, randomized study phase, everything looks good. Okay, we're going to go ahead and fix the test trial right now. So we're going to switch it to the image stimuli. It's selecting all the rows, so that's just fine. It's a random order. All we have to do is go in here, add the image. We'll call it image test. We'll make it an infinite duration. Image file is the variable that it should read from the Excel file, and we need that to set every time the loop repeats. Click OK, and we can remove the text object. Alright, so if we ran our experiment now, we should basically have a simple recognition experiment. Now, one other thing to remember to enter here is we set the study duration for our study image to infinite. We need to add a keyboard response. So this is going to be key study. And I'm going to let people say 1, 2, 3, 4, 5, or 6 here, and I will explain that in just a moment. And by the way, I need to go in, this size of the image is set correctly. In my test phase, I never set that up correctly, so let's go ahead and make this consistent. So the images should be the width of 2, which is the entire width of the screen, and the height should be 0.7. Okay. Now if I run the experiment, I have a basic recognition memory experiment. I have some decision that's being made at the study phase that I haven't quite explained to you guys yet, but that's okay. Oh, and as before, we've encountered our notorious PsychoPy loop bug. So it does not like the single quotes being around the 0 through 6, so I'm just going to remove those. And now PsychoPy should run correctly. I feel like every time I make one of these videos, I encounter this bug. It's okay. Sometimes it needs a single quote, sometimes it doesn't. And here is our study phase. So we have our 6 images being shown one at a time. The images, the dimensions look pretty good. Get the researcher, and then they just have to say yes or no here. Yes, no, etc. All right, so why am I having people make ratings at the study phase? So in the context of this experiment, these are the instructions that I'm telling you I'm hypothetically giving to subjects. I'm asking subjects that every time they see an image, they should decide whether this is an image that they've seen before, whether it is an area of the city that they know very well. And I'm going to ask people to press a number from 1 to 6, with 6 indicating that they know the area very well, and 1 indicating that they don't know the area at all. So, like we saw in our previous tutorials, in conditions like this, it's helpful to add a scale to the screen. So let's go ahead and add a scale. So I'll add a text object called study scale. It will appear forever. We're going to have it appear below the vertical center of the screen, and we'll just go ahead and fill this out, 4, 5, 6, and we'll say 1 is if you don't know the place, and 6 is if you know it very well. And that's okay for a very rough scale. And if we hit run again, we'll see this in action. So some of this stuff is review from other videos we've seen before. So we can see our scale is actually appearing on the image, and the alignment is kind of off. So let's go ahead and fix this. So we need to move this to the right more to align better with the text. This needs to be further down. How about negative 0.5? That seems pretty low. So if we hit run now, then hopefully everything should look good. Good enough. We could move it down a little further perhaps, but that's totally fine. So we're asking people, is this an area that you know or is unknown to you? And people make their ratings. Now, the reason we have subjects making ratings during the study phase is that in the test phase, what we want to do is separate out areas that people know versus areas that people don't know, and look to see if the hit rates, if their ability to recognize items they studied is better or worse for areas that they know versus areas that they don't know. So it's a simple prediction. Maybe you could predict that if you know an area, you'll have better memory for it later on than if you don't know an area. I mean, that intuitively makes sense. In order to do that, we need our study scale that gets ratings during the study phase. We get our test ratings of whether people actually recognize the item. They're only making a simple yes-no decision here. And the trick will come when we look at our data file, because what we'll end up doing is sorting out study items based on whether they were known or unknown. So I'm going to go ahead and run this experiment a couple times, get about 3 subjects worth of data, and then we're going to look at that together. So here's the data from our 3 subjects. I'm going to copy these 3 CSV files and go over to my script folder. And I'm going to pop into my raw folder here. I'm going to delete the files that I had here before. Those are from the word experiments, and I'll paste in my data from the image experiment. I'll open this up in Genie, and I'll hit execute. And that should have created my merged file. So I'm going to call this the images merged data, and I've actually created a new folder in here called analyses. Here's the word files we were working with before. I'll paste the images one in here and we can go ahead and get started on this. So here's the data from my experiment. You can see which image subjects saw in every given trial. You can see its old new status. You can see what kind of rating the subject gave it. You can see what kind of rating they ultimately gave when it came time to recognize the item. So all the same stuff we saw in our word stimuli. First thing we're going to do is resave this as an Excel workbook, so that if we create pivot tables and equations, none of that stuff gets lost when we close our file. The next thing we're going to do is create a new sheet, and we'll insert a pivot table just like we did with our word stimuli. Everything works the exact same way. We'll select all of our items. And if we want to do a very preliminary analysis of the data, we can sort old and new, and we can go and calculate out the probability that a subject said yes. So we're going to need that extra column. So like we did in our first data set when we had words, we're going to use an equation to calculate out the probability that an item was said yes to. And I'm just going to go back and copy this equation from my previous Excel file. If you need a refresher, go and check the first data analysis video. So you can see my equation here. I check to see if this column is either a y or an n. So I have my or equation here. If it is, then my P yes cell checks to see if this is a y, and if it is, then my P yes cell becomes a 1, otherwise it becomes a 0. And if this is not a y or an n, then nothing goes in there instead. And this fills out my table. So if I go over to my pivot table, and I remember when you add new columns, you have to change your data source, and you have to reselect your data to add in that new extra column. So go ahead and click yes. Now PS shows up. I can drag it into values, change it to an average, and I can see the likelihood or the probability that subjects would say yes to old items or yes to new items. Now you'll notice that the false alarm rates are very high here. I was basically responding randomly when I was doing this experiment, so don't read into this. This doesn't mean the experiment failed. This is just me sort of behaving randomly just to get the data files. Okay, so now what happens if we want to take these studied items and say we want to sort them by items that were familiar to subjects, that subjects knew, the 4s, the 5s, and the 6s, and separate those out from the items that were 3s, 2s, and 1s? Well, it's very easy to write an equation here that checks to see what value this number is, and if it's greater than or equal to 4, then it assigns it a value of 1. If it's less than 4, it assigns value of 0, and you could say 1 is a well-known street and 0 is an unknown street. But the problem is that that doesn't actually help you, because we don't really care. We don't need to know necessarily whether each study item was known or unknown. What we need to know is for each test item, when it was shown at study, was it known or unknown? So we need that information down here in the test phase. We don't need it up here in the study phase. So that's what makes this a little more tricky of an issue. How do you tell Excel to basically, for each item at test, look up how familiar it was at study, and then sort things down here, assign some kind of values? This item was known or unknown at study. So there's a couple steps to this. First, we're going to create a column that we're just going to call tag. This is going to be an item tag that is basically going to be the stimulus name plus the subject's number. And the reason we're doing this is, let's use this first test item as an example. Let's say we want to look up and see what was this item rated when it was seen at study. Actually, this is a new item, so let's imagine for this item right here, we want to know for this image, when it was shown at study, so it is the first item that was shown at study, what did subjects rate it? And we want Excel to be able to look up this image and find out that it was rated 6. So the way we do it is we're going to use a search function in Excel, and we're going to tell Excel to look for this image, but only look for this image for this subject, for subject number 1. Because other subjects also saw that image, but we don't care what they rated it. We want to know for subject 1, what did subject 1 rate this image when subject 1 saw it? So in order to do this, we need a column called tag, and the tag is going to be a combination of the stimulus file name and the subject number. The way we combine things in Excel, the way we combine text things, is with a function called concatenate. Concatenate. And it asks for different text items to concatenate together. So all we have to do is click on the stimulus file, then put a comma, and then come over here and click on the participant number in the correct row. Then we can close the bracket and hit enter. And now you'll see our tag for this item is this image file name with a 1 at the end. So we can go ahead and copy this, and we don't have to worry about what cells this fills in. We'll just copy it down, keep it nice and simple. And so you can see here the 6 images that subject 1 saw, and at the end of each of those images are 1. And here are the 12 images that the subject saw at test with a 1 at the end. And you can see for subject 2, they have different tags. They have the same image names, but they have a 2 at the end rather than a 1. So when we want to look up subject 1's image, we can, because we can just put a 1 at the end of any image we want to look up. Alright, so let's look up this image here, the one on row 11. This is the first old image that we've got, and we want to know, what did the subject rate this image? So we're going to create another column here, and we'll call this study rating. You can call it whatever you like, really. It's basically, we're going to look up what the study rating was for each item at test. The way we do that is with a function called VLOOKUP. And actually, before we get going on VLOOKUP, there's actually one more thing that we need to insert here. This seems a little redundant, but we need these values here to appear right next to the tag. So here's how we do that. We just basically pick the first cell over here, put equals, go over to the cell that we want to copy and just hit enter. And again, we can do this for all the cells all the way down. It doesn't matter that we have a bunch of zeros. And we just need a label here. We'll call this key study. All right, going back to VLOOKUP. Let's enter our equation here. VLOOKUP. And when we open the bracket, we have a couple of variables that we need to give to Excel. First, it wants to know what is the lookup value. Basically, what is the tag that we're going to be looking up? And we can just click right here. This is the tag that we want to find. This is the name of the image file that was seen at test with the subject's number at the end. And we want to find this in the study phase. We'll put a comma here. Then it wants to know the table array. We're just going to select these two columns here, Y and Z. And we're going to put a comma. Then it wants to know the column index. Now the way VLOOKUP works, it's going to take this value here and it's going to try to find it in the table, and it will always look in the first column. So it's always going to look in Y. Once it finds it, so hopefully it finds it right here, it will then return a value from one of the columns. The way we indicate which column we want is by giving it a number. If we say column 1, then it will return this value, because this is column 1. If we say column 2, it will return this value here, the 6, because this is column 2. If we had 3 or 4 or 5 or other values that we wanted to look up, as long as they are in columns that followed column Z here, then you could indicate column 2, column 3, column 4, etc. You'd obviously have to select a wider range here, but for our purposes, again, there's just one value we want to look up, and it's in column 2. Lastly, VLOOKUP, do you want it to find an approximate match or an exact match? We want an exact match. We don't want to kind of find this tag. We want to find only this exact tag. So we're going to hit false. And then we can close our brackets and hit enter. And lo and behold, it finds the 6. Now, there is one thing actually that I realized as I was typing that equation we need to do, which is we need to get these tags out of the test phase because we want VLOOKUP to be finding the items from study. We don't want to accidentally find items from test. So we don't want VLOOKUP, when it's trying to find this item, to accidentally find this row and return a 0, because that is not helpful. Now, it should never happen that way because the study items, the study results always come before the test. But at the very end of the video, I'll show you how to fix your equations so that basically these tags are blank. And so there's only tags from the study phase, and you can be absolutely sure that you're going to be looking up the correct value here. For now, we're just going to leave it as is because it will probably work okay, but just be aware that it is open to some potential bugs. So we can try and find this image here. These images, these file names are not great for looking things up, but the last couple digits here are 1436. If we look, we find 1436 in the study phase. It was given a rating of 3, and that's what we're getting here. Here, the last 4 digits are 8439. 8439 was given a rating of 2. You can see that what Excel is doing is it's referring back to here, trying to find the name in the study phase, and when it finds the name, it's going over to column 2. This is column 1, this is column 2, and it's getting this value and inserting it here. So we could copy this for all of our subjects. And now what we've done is we have figured out what the study rating was for each of the test items. And you can see all the new items have a rating of 0 because the only entry to find are the entries in the test phase. And so when Excel tries to find this tag, it starts searching through and then it finds it right here. It finds itself, and itself had a rating of 0. So that's why it's getting the zeros. Now if we wanted, we could create another column called known and unknown, and we could use an equation and basically say, if this is equal to 0, then this is a new item. Otherwise, if this cell is greater than or equal to 4, then this is a known item. Otherwise, it's an unknown item. If that is greater than 4, it's a known item, otherwise an unknown item. And of course, we could add another if statement to make sure that it doesn't fill in cells outside of the test phase, so this cell should be blank, and we could add an if statement around it. Refer to my earlier videos if you want to see how to do that. But for today, we're just going to manually copy down and make sure we're still in the test phase. So you can see that now we have sorted out items at test, whether they were new, known, or unknown. We can go back to our pivot table now. We can change our data source, and we can now select all those new columns that we calculated. And now if we wanted, instead of old, new in the columns, we can include known and unknown rating. And we can see for known words, or known images, I should say, what is the likelihood of saying yes? It's 0.5. For unknown, it's 0.5. And for new items, it's 0.6. So again, this is kind of random noise data because I was just sort of mashing on the keys. But as a proof of concept, this is how you would actually sort the data out. So VLOOKUP is a very powerful function. If you know how to create proper tags, you can look up almost anything from earlier in the experiment. So if you want to know how long subjects took to press a key during the study phase, then what you could do is you could insert a column here called study RT. You could make it equal to the reaction time of the keys. Oh, and make sure you have it right next to the other column, because remember you have to have a table like this. I had it over here so it wasn't going to work. And in your VLOOKUP function, if we just extend the table that it's looking at and we change it from looking at column 2, which is here, to column 3, which is here, then what you'll see is that now we don't get the study rating. We look up how quickly subjects responded to items at study. And we could have an equation over here that sorts out if it's longer than a second or under a second. There are different kinds of items and so on. So using VLOOKUP to successfully look up how study items were treated can be very useful for sorting items at test. So I'm just going to undo my changes here. Now I promised you one other correction here, which is how do you make sure that items don't accidentally look up themselves. So all these new items ended up looking up themselves because it's all they could find. And we wouldn't want a study item to accidentally look up itself. And we want to guarantee that our equation doesn't lead to that. Well, if you go into your tag equation here, you basically need to only create a tag if you're in the study phase. So we can add an if statement here. And the if statement can check to see if this cell is not blank. Because if the cell isn't blank, we're in the study phase, you can go ahead and create a study tag. Otherwise, make yourself blank. And if we press enter on this, and we copy this all the way down, what you'll find is now the tags are only created in the study phase. So again, the equation is to first check to see if there was a study response, because if there was, it's a pretty good indicator that we're in the study phase. And if we are in the study phase, then create a tag, which is the stimulus name plus the subject number. Otherwise, if we're not in the study phase, just leave the cell blank, which is what happens here. We also have to go in and change our VLOOKUP function. So before we were using the tags that were here to look stuff up, but you can't do that because the tag isn't there anymore. So rather than looking at Y10, we're just going to use concatenate again, and we're just going to recreate the tag that we're looking up. So again, we're looking up the image file, comma, and the participant ID, close brackets. So our VLOOKUP function looks up image file plus participant ID. It looks in this table, which is columns Y and Z. It looks in column 2, so it's going to try and find the tag in the first column always, which is Y. And then when it finds it, it's going to return the value from the second column, which will be the key that was pressed. And it will only look for exact matches. That's what this false is about. We'll press enter, copy that down, and you'll see that for study items, it is finding them. For new items, items that don't have a tag in the study phase, it's basically returning an error. And so here's one more Excel function you can use. Over here in your VLOOKUP function, we can use a function called if_NA that will basically say, I'm going to try and do this VLOOKUP that you're telling me, but if the return value is NA, which is appearing here, then take on some other value, and we're going to give it a value of 0. And So what is happening is it's trying to look up the study rating, and if it can't find anything, it returns NA, which is an error, but we're surrounding our VLOOKUP in a function that says, if you are an error, if you are NA, then take on a value of 0. So this may seem like a long way to correct what was essentially a working setup before, but this is the more proper way to do it. In our previous setup, the new items were technically malfunctioning by finding their own tag when they were looking themselves up. But in this format, it's not possible for an item to find itself. It can only find the study phase version of itself. A test item can't find its own test item and accidentally take that rating. So this is a much safer, much better way to do it. So there you have it. This is some of the most advanced type of stuff that we ever do in Excel. It may seem a little tricky, but again, there's lots of videos on how to use the VLOOKUP function on YouTube. You don't just have to look at my videos here. So if you still have more questions, you might want to Google it and see if you can find a video that addresses your question. But in the basic setup, if you followed all the steps, you should at least have a working Excel sheet here. And you should be able to go ahead and play with it and change some values and see how it looks up information. So go ahead and give that a shot. It's a very useful ability to be able to sort your data in this way and to be able to process your data in this way. So definitely make sure you're giving it a shot. Anyway, that's it for today. And so until next time, guys.